So let me repeat again this calculation.
Repeat the calculations.
Again. Repeat the calculation to determine how much must be deposited for the second and third withdrawals. So for the second withdrawal, P equals 1,000 times 1.1 to the power negative 2, and this gives us 826,45 rands. And for the third withdrawal, P is 1,000, 1 plus 0.1 to the power negative 3, and that is 751.31. So we must note something, so that for each year's withdrawal, the deposit required gets smaller and smaller and smaller, because it will be in the bank for longer and therefore gain more interest. So deposit for second and third withdrawals is smaller because the money stays in the account longer. Money in the bank for longer. Money is in bank for longer, and earns more interest. Therefore, it earns more interest. Interesting. Why am I writing interesting? Because I said interesting. That's why. So the total would be the sum of all of those, and so the total is 909.09 plus 826.45 plus 751.31, which is 2,486.85. Right, and initial deposit or rather, let me not do that. Let me say instead, there's the initial deposit, there's an amount after 1 year. At year 1, there's an amount after withdrawal 1. So WG is withdrawal. WG is withdrawal. Then amount at 2 years. And then amount after withdrawal 2. And then an amount after 3 years. At year 3, and an amount after withdrawal 3. Right, so the calculations are as follows. So in year 1, we Okay, so just to check on these calculations, we have, just want to see, that's the total times 1 plus I, total minus 1,000, 1 plus I. Okay, cool. So remember from our formula, A equals P 1 plus I to power negative n, right? The part 1 plus I to power negative n, that's the compound interest part, right? Compound interest. That being said, the amount after year 1, we leave it blank, or rather initial deposit, we leave it blank because, so I'll just put calculation there. And then here I'll put accumulated amount. Okay, so the initial deposit, so every year 1,000 is deposited, right? Now we want to find if Kate has to withdraw 1,000 every month. Like, we're working it out in reverse. So how much will she have to withdraw to deposit now, so that in a year she can withdraw 1,000? How much will she have to deposit, I guess now, but like in a 2-year period, so that she'd be able to get 1,000 in 2 years' time? And how much would she have to deposit now, but so that in 3 years' time, that money she deposits now is $1,000? Yeah. So the initial deposit, we can leave that as blank because of that, because we know that at the end of 3 years, she will have had an accumulated amount of 2,486 and 85 cents. After 1 year, it changes by wait, something I'm not doing right.
This table is confusing.
Yeah, I'm also a little confused by it, because maybe let's leave it out for now.
Come back to it.
Because I thought it would help us derive the formula, kind of like how we did it with the other one. So I'm just gonna go straight into deriving the formula for present value annuities. So we know that the accumulated amount is 2,486.55, and it equals the sum of 909.09 plus 826.45 plus 751.31, and this is 1,000. 1 plus 0.1 to the power negative 1 plus 1,000. 1.01 to power negative 2 plus 1,000. 1 plus 0.1 to power negative 3. All right. And this is a geometric series.
Isn't this the same as the derivative as deriving for future value?
Yes, it's a similar approach.
But the only difference is that we swapped.
Yes, P is now the subject of the formula.
Yeah, that as well as the structure of it.
It's because we have a negative exponent in the second case.
The first.
In the first case, we had a
case we have the
negative exponent. Yeah.
You see, sir, the 1 is no longer minus 1, it's 1 minus.
Yes. So we're gonna come to how this is derived like this.
So the same way as I get a form for a geometric sequence.
Mhm.
We have two formulas for when a is greater than 0 and a is less than 0.
It's when the ratio is greater than 1 and when the ratio is less than 1. Yeah. So this one is for the ratio that is less than 1. Because in the other case, we did for the ratio that is greater than 1. So our ratio is less than 1 because already the exponent is negative.
Yeah.
So now we're going to use the case of sum of so many terms is the first term times 1 minus r to power n over 1 minus r. So we're going to use this one for r is less than 1. For r is less than 1. And our first term is 1000 times the constant ratio of 1.1 to power negative 1, and the number of times the series, or rather the number of terms to which we must add the series is 3. Therefore, sum of the series would be 1000 into 1.1 and open square bracket 1 minus 1 plus 0.1 to the power negative 1. Oh yeah, r is that and it's raised to the power 3, right? Remember, I'm just gonna go to the previous page now.
Okay.
Our a is this one here, right? So in this equation, it is this one here. That's our a, first term. Yes?
The 3 stands for after 3 years.
It's for this part here. Remember in the formula, n corresponds to this one day. Sharp. So now when we're substituting it into that formula, it is that part there.
Yeah, I'm asking if it's for the number of years or the number of withdrawals that she's going to make each year.
Yes. That's for the number of withdrawals that are going to be made over the 3-year period, which is 3 times. 1 minus r is 1.1 to power negative 1, because r is this one here. So I'll just make it yellow. And it was all yellow. See? Then what happens is that we have this is interesting. Okay, so this times, or rather.
You could say when you take this down, it becomes a positive. And the exponent becomes positive.
Oh, this one here. Yes. So it becomes 1000 divided by 1 plus 0.1 to power negative 1, positive 1 this time, because it's now a denominator. Sounds like a name of a villain, a denominator or a hero.
The denominator.
Yes. Or like a magical power of a device that they use against evil or something.
A superhero Numerator.
Yes.
No, it sounds like a machine if I would use.
Yes, something like that. That's what I
You've
want.
watched Phineas and Ferb, right?
Yes, I have.
Right.
The
Dr.
scientist guy.
Doofenshmirtz.
Yeah.
Yeah. It sounds like something different Dr. Doofenshmirtz would make.
Yes.
The numerator. Dun, dun,
Numerator.
dun.
Dun, dun, dun. Yes, it sounds like that. 1 minus 1.1 all right. So they took that one and made it a denominator. A denominator. And then okay, something is extra here. And this is what's extra here. Yeah, that's what's up. Then if we take this and multiply it by 1, we get that, right? And this, if we multiply by that, we get 1. So that's why we get that there.
Mm-hmm.
So if we take 1.1, we multiply it by 1, we get 1. But if we multiply it by its inverse,
so
we get 1. What's so long? I
Like they're being so extra.
don't know. Because they want to be.
Like they like the rhymes.
Yeah, it is what it is. Maths can be like that sometimes.
Like so they like being 0.
And this is 2486.85. But now this amount is actually
This amount.
yes.
I'm gonna show you that amount.
So
That amount.
the amount down
Accumulated
there.
amount.
Yeah. So I think what the bigger picture of what we're learning here is, as you have, if you have a loan of, let's say, so much, then over time, to pay it back, like you get the money now, but then to pay it back, you're not gonna pay the same as when you got issued to you. That's the important thing we need to learn. As the loan reduces, it's charged a compound interest at a certain rate. So the compound interest, I guess it's summed up and reduced onto the size of the loan. Yeah. And then the formula from that becomes, so when we're deriving the formula, so when we're actually deriving the formula, first term is x into 1 plus I to power negative 1. The ratio is 1 plus I to power negative 1. And then the sum would be a 1 r to power n over 1 minus r for r is less than 0. Then we have x into 1 plus I to power negative 1 into 1 minus 1.1 plus I power negative 1. But this also goes to power n. Yeah, let me just do that. 1 minus 1 plus I power negative 1. Then this becomes x into 1 minus 1 plus I negative 1 n over 1 plus I into 1 minus 1 plus I to the power negative 1. And then we're going to get the same effect, so it's going to be x into 1 minus 1 plus I to the power negative n, and this becomes 1 plus I minus 1. And this equals x into 1 minus 1 plus I to the power negative n. All of this is over, that's 1 plus negative 1 I. That's the equation. Present value. And then this is just the present value. So it's a present value of a series of payments. Whereas the payment amounts would be something else. So this is how much would be paid back at a regular interval. So it'd be x equals P for Mr. P times I.
P times interest.
Yes, P times interest. 1 minus 1 plus I to the power negative n. Yo. Okay, cool. Now let's quickly do a worked example. So Andre takes out a loan for his first year of civil engineering. Oh yay! Coincidence.
So this one is favoring you, right?
Eh?
But it's favoring you, right?
Yeah, this one is favoring me. This is on page 120. Right? Guy takes out a loan. The loan agreement states that the repayment period equals to 1.5 years for every year of financial assistance granted, and the loan is subject to an interest rate of 10.5% per annum, compounded monthly. Compounded monthly.
I'm trying to ignore it. Oh.
You were trying to?
Yes.
Oh,
I was trying to.
So the repayment period equals 1.5 times every year of financial assistance grant.
Okay, so for 1 year they assist you, you have to pay
1.5 times the amount.
So like
So if they've
you
assisted
pay an
you
extra 5 months. No,
yeah,
an extra
6 months, yeah, worth of whatever financial assistance they gave you. So if Andre pays an installment of 1446.91, calculate the loan amount. So what is P? We're looking for P, ne? Alright, so we know that our present value is x into 1 plus tron, so we shall just say P is x into 1 minus 1 plus I to the power negative n. All this is over I. We've got x, we've got I. So our interest would be 0.105 over 12 because it's compounded monthly, right? And we also need to take an important term into consideration, which is 1.5 times 12, which is 18 months. That's the number of months he's going to pay it off if he took out he took out how much? Or if his installment is 1.1446, 446 Rand 91 cents, then the size of the loan is 144.6.91 rather, into 1 minus 1 plus 0.105 over 12 to power negative 18 over 0.105 over 12, and that equals 24,000. Okay, so you took out a loan of 24,000 bucks. Wow. So at the end of and then the second part of the question is determine how much interest Andre would have paid out on his student loan at the end of 18 months. So the interest would be, so total amount would be the payments times the number of months, which is 1446.91 times 18, and he will have in total paid 26,044 rands 38 cents. Then the interest would be total amount minus loan amount, which is 26,044.38 minus 24,000, and that's 2,044.38. Okay, so basically we are calculating how much a loan or bond payment would be based on how much a person is paying as an installment. All right. And then
So do you ever use this?
yeah, sometimes.
Do you?
Why?
Because most people do.
Yeah, I mean, that's useful.
It's like it's there for decoration.
Oh no, it's very useful, that thing. Okay, then let's do another worked example. Number 9, where we calculate monthly payments, and it's on page 121. Okay, and then we're told that Risto wants to buy a small wine farm worth 8.5 million.
That's a lot.
He then plans to sell his current home for 3.4 million, which he will use as a deposit to purchase the farm. He secures a loan with HBP Bank, and the repayment period is 10 years. So repayment period is 10 years, and the interest is 9.5 just now, 9.5% compounded monthly. It's compounded monthly, yes.
So like if he sells his current home, where is he going to live?
On the farm, it has a house.
But like,
I guess the farm is not just land. There's a house that manages.
I know, right? Like, no matter what, if it's just like a plain blank farm, it's just like
No.
a land bridging.
No, can't. No, there's a big chance. There's a big chance that the land has a
It's
part where
pre-owned.
people can it's pre-owned, and there's where people can live. There's a big chance. So it's compounded monthly. So we take that 9.5% interest rate and we divide it by 12. Alright? Now we're told that the farm is worth 8.5 million rands. And he puts up the house he sold for 3.4 million rands to get what he actually has to ask for a loan. And what he actually has is 3.4 million, but now what he can ask for a loan for is 5.1 million rands. Right? Now if we want to determine, first we have to calculate his monthly repayments. So he must get a loan of 5.1 million rand, right?
Could do a lot of things with that money.
So we must work out monthly repayments, which are P times I over 1 minus 1 plus I to power negative n. And this equals 5.1 million times 0.095 over 12. Aga? Over 5 times. Okay. And then I could we're told that he has to repay this over 10 years. So over 10 years, every month he's going to pay the same installment. So now that's where N is going to look like 12 months times 10 years, which is 120 months. Alright, so when we substitute, we will have 1 plus 0.095 over 12 to power negative 120. And this equals to such a big loan repayment. So Risto has to pay 65,992 rands and 75 cents every month for the next 10 years to repay his loan. So that means if Ajalam Rahokua, he has to make sure that at the very least the spinach product output should give him at least 70,000 rands, just so he can pay back the loan.
Okay.
We haven't even calculated his groceries, his living costs, his salaries,
Paying his workers.
paying his workers, the equipment, the irrigation, the electricity, fertilizer, and also depending on the type of farm, feed. Farming is work. And then you have a drought.
Not really.
And then you get a drought and you can't make money.
And now you're
Now you owe them, and it's not your fault, it's the weather's fault. Yeah, that is something. So now, to calculate...
I hope it works out for you still.
Hmm?
Yeah, I hope it works out for you.
I think it does. I think it will work out. So now, we have to work out the total interest by the end of 10 years. So at the end of 10 years, the interest would be, the total amount paid would be 65,992.75 times 10 years times 12 months, which would be 7,919,130, and the total amount of interest would be total amount versus loan amount, which would be 7 million rather. 919,130,000. Ash, I'm not. I'll answer that just now. 5,100,000, and the total interest paid is therefore 2,819,130. Wow, so there's always an interest that you pay. That's not nice. Okay. The prime lending rate, and they always mention this in the news, ne? Have you heard? The prime lending rate. They always mention this in the news. People who own homes and they live in suburbs, they often talk about, hey, when it double digits, interest double digits. And then the newsreader will hold in prime lending rate. The prime lending rate soared today as the Reserve Bank.
Maybe I missed that part of the news.
Well, now we'll get to watch it.
Because we watch at home, we watch Newsroom Africa, right? And then on Newsroom Africa, we don't have a weather break. We don't have where they talk about the markets. No.
Really?
It's there at the bottom.
That's why you don't pay attention to it.
Because
So
the only time I pay attention is when they're talking about the weather. But when they're talking about the markets down there,
lending rate.
yeah.
So anyway, we're told that it's a benchmark, mark bench, at which private banks lend out money to the public. For private banks to lend money to the public. Alright, cool. It's used as a reference rate for determining interest rates on many types of loans, including small business loans, home loans, and personal loans. So it's like a reference rate for interest rates on multiple types of loans and some interest rates may be expected or rather expressed as a percentage above or below the prime rate. For calculations in this chapter, we'll assume the prime lending rate is 8.5%. So assume prime lending rate is 8.5%. Right. Remember, it is the benchmark rate at which private banks lend out money to the public. Okay, cool. So in worked example 10, a school bus sells its old bus and uses the proceeds as a 15% deposit on the purchase of a new bus, which costs 330,000. So the bus costs 330,000, and after they sell the old bus, what they have is the 330,000 minus 0.15 times 330,000. I'm correct to say minus because the old bus, when sold, it only amounts to 15% of the price of the new bus. So we can say 330,000 minus 0.15 times 330,000. And that gives us how much? To find the balance of the purchase, the school takes out a loan, or to finance the balance of the purchase, the school takes out a loan, and when they take out a loan, the loan is subject to an interest rate of prime plus 1 compounded monthly. So interest is 8.5 plus 1 compounded monthly. Divide by 12. So 9.5 over 100 divided by 12, which is 0.095 over 12. Alright. So we must find monthly payments, which is 1 minus 1 plus I to power negative n, and so then this is how much?
280,500.
500. Alright, 500 there. Then when we substitute that as a principal amount, we've got the interest rate, it's 0.095 divided by 12. And n also equals, what was the other information we were given? The repayment period of the loan is 3 years. The loan is going to be paid over 3 years, so it's 3 times 12, so it must be paid in 36 months. Right. So that means X is 280,000 times 0.095 over 12, divide by 1 minus 1 plus 0.095 over 12 to power negative 3. 6. Yes. And this equals 8,985.24 a month for the next 3 years is what the school must repay. Then in the second part, the balance of the loan must be determined at the end of the first year, immediately after the 12th repayment. So first year would be at the end of the first year.
It means we're calculating for 35 months.
For 12 months, the first 12 months.
12 months, so we're calculating for the next 24 months. Right.
We can calculate the balance of the loan at the end of the first year by determining the present value of the remaining 24 repayments. Yes, that's what we can do. So that means
we have a way of complicating questions.
Who, me?
Yes.
And it's because I guess I'm always trying to understand things from a different perspective. I wouldn't choose the word maybe different.
It is complex.
Askies.
Because you know what you do, like, I'd say something and then you twist it. We're saying the same thing. However,
I'm paraphrasing.
You are complicating it even more.
I'm paraphrasing. Askies if I'm complicating. I'm so sorry.
We're saying the same thing, but why do you have to make it sound more sophisticated?
It's not making it sound sophisticated. I'm just paraphrasing.
You can say it's paraphrasing. You're paraphrasing. You're making it sound sophisticated. I'm not saying you're wrong. I'm saying you're making it sound sophisticated.
Okay. Well, thanks for that. I received. Alright. So it would then be the installments times y minus 1 plus I to power negative 24. So the question was, determine the balance of the loan at the end of the first year. Oh yes, so in other words, after paying for the first 12 months, what's remaining to pay for the, yes. Okay. So in other words, balance of loan at end of 12th repayment means what's left to pay over 24 months.
It's the 36 months minus 12 months. You
Yes.
get 24 months.
Alright. And then that's the first way that it can be done, and the answer is simply 195,695.07. And it can also be calculated by,
Is this one?
therefore balance equals
Sushi.
A minus F. So a loan, which one is that? This one. If the total number of payments is not known,
Well, we know this one, but this is what we're using.
this one here. Oh, so now we find it. So in the first case, the total number of payments is known because we have the 36. Okay, so here, balance is x into 1 minus 1 plus I power negative n over I. And in this case, balance is gonna be P for Mr. P, thank you, plus I power n minus x into 1 plus I power n minus 1 over I. And if we think about it, this is kind of like saying future value, compound interest, yes, loan and accrued interest. Oh, so loan and accrued interest in this part here is simply first year's payments and interest. Okay, first 12 months payments and interest. And then, yeah, so when we substitute, then we'll get 202, 500, 1 plus 0.095 divided by 12 over 12 minus 8985.24 into 1 plus 0.095 over 12 to power 12 minus 1 over 0.095 over 12. And this answer is equal to 195,695.15. Alright. Present value and our relatives. We can stop here for the day. I'm starting to feel a bit tired now. And Wednesday when we meet up, we're gonna do exam questions that have this type of stuff. Yeah. Wednesday when we meet up, we're gonna have exam questions that have